Let's start with lesson 1 fraction. So first we'll look at fraction general form. It is A over B, where A and B are whole numbers. So for today, we just look at A and B are whole numbers. In case A and B are not whole numbers, like for example decimal numbers, then we'll talk about it later. So for fraction, so the top part A, we call it is numerator, and for the bottom part B, we call denominator. Okay, we have some example for fractions, like 1 over 2, 3 over 5, 6 over 7, 10 over 9. Yeah, so we can have a lot of examples about fraction. And there are some cases about some cases of fractions. We'll go over case by case. So case 1, we have a fraction A over B, where A equal B. So in this case, A and B are equal each other, and the fraction A over B always equal to 1. Let's take an example. If we have 1 over 1 equal to 1, 3 over 3 equal to 1, 2 over 2 equal to 1, 4 over 4 equal to 1, 5 over 5 equal to 1, so on and so forth. Okay, and even we have a 9 over 9 also equal to 1. Okay, it does not matter what number of A and B are, so long as they are equal each other, the fraction is always equal to 1. Okay, so that's case 1. So due to this property, so 1 always can be written as a fraction of in which A equal to B. Okay, like we can write 1 as 1 equal to 1 over 1. We can write 1 equal to 2 over 2. We can write 1 equal to 3 over 3. We can write 1 equal to 4 over 4, or 1 equal to 100 over 100, 1 equal to 88 over 88, so on and so forth. So why I talk about this one? Because later when you do addition, subtraction of fractions, we need to know this thing. Okay, so that's the case 1. Now we'll go to case 2. Okay, so case 2 is A. We have a fraction A over B, where A is a multiply of B. Okay, so A is a multiply of B. Let's take example. Okay, so we have A over B, like we have a 2 over 1, we have a 6 over 3, we have a 4 over 2, we have a 9 over 3, we have a 10 over 5, we have a 24 over 6. We have a 36 over 9. We have a 64 over 8, so on and so forth. So in this case, you can see A is a multiply of B. The first fraction, 2 over 1. Okay, so A is a twice as B, right? And 6 over 3, same thing. 6 is a twice as a 3, so A is a twice as B. And similar, we have a 4 over 2. So for this example, 9 over 3. So A is a 3 times SB, right? And then 24 over 6, we have A is a 4 times SB. And we have a 64 over 8. So A is 8 times SB. So if A is a multiply of B, then we can write the fraction A over B as a whole number, and it is equal to whatever the result you get when you divide A divided by B, then it is the whole number from the fraction A over B. For example, 2 divided by 1 is 2. 6 over 3 is 6 divided by 3 equal to 2. 4 over 2 equal to 2. And 9 over 3 equal to 3. And 10 over 5 equal to 2. 24 over 6 equal to 4, because the 24 divided by 6 is 4. Or 36 over 9 equal to 4, because the 36 divided by 9 is 4, right? And 64 divided by 8 is 8, right? Yeah, so also due to this property, so you always can write a whole number, any whole number, as a fraction, such that the whole number is a result of the numerator divided by the denominator. For example, if I take a whole number 2, I can write number 2 as 2 over 1. I also can write number 2 as 4 over 2. 2 we can write as 6 over 3. Or 2 equal to 100 over 50. Or 2 can be written as 200 over 100, right? So one whole number, you can write it as a fraction in many ways, many different ways. Okay, it's similar. 3 we can write as 3 over 1. We can write as 9 over 3. We can write as 6 over 2, so on and so forth. So that's a case 2 of fraction. Okay, so from case 1 and case 2 of fraction, we can see like, so we can conclude that whole numbers always can be written as a fractions in different ways. Okay, the case 1 is a special case, like the denominator and the numerator are equal to each other, and it is always equal to 1. So fraction is always equal to 1. Okay, and it also can be written in many different ways. Yeah, and the case 2 is A is a multiply of B, and we also can write a whole number as a fraction in many different ways. Okay, so case 3. So for case 3, A over B, where A and B are not case 1 and case 2 above, but A and B have a common factor. Okay, so let's take an example. If I have a fraction 15 over 6. Okay, so you can see both numerator 15 and denominator 6. Both of them have a common factor. It is a 3, right? Because the 15 can divide by 3 and 6 also can divide by 3. So how can you find this a common factor? Okay, this case is a similar, it's a very simple because it's a 15 over 6. So you can look at the multiplication table, and then you know the common factor is a 3. But if you deal with a fraction, if you see a fraction where the numerator and the denominator are big number, for example, if we have something like, let's say 99 over 69. Okay, in this case, so how can you find a common factor of 99 and 69? Okay, so let's talk about it. We will get the first example, this one first. Okay, so 15 over 6. So if you still remember how to write a number as a product of prime numbers. Okay, so we have a 15. We use the Chi method. So 15, we can 15 can divide by 2. No, of course no, right? So because 2 is a prime number, so I just want to start with 2. So 2 is not the answer. Okay, so 15 can divide by 3, correct? Yeah. So 3 is a prime number. Yeah. And 15 divided by 3, so we have a result 5. And 5 here is a prime number, so we stop here. Okay, so 15 can be written as a product of 2 prime numbers, 3 times 5. Okay, similar we do for 6. So 15 here, 6 here. Okay, so for 6, we also start with 2. So 6 can divide by 2? Yes. And 2 is a prime number? Yes. So we write it here. Okay, and 6 divided by 2 is a 3. So 3 is a prime number? Yes. Okay, then because 3 is a prime number, the result is a prime number. So that's why we stop here. We cannot do any further division. Okay, I mean we cannot do any further branch, okay, of the tree. So we circle 2 and 3, and now we write 6 as a product of 2 prime numbers, 2 times 3. Okay, and we look at here, 15 is a product of 3 and 5. 6 is a product of prime numbers 2 and 3. So both of them have a 3. So it means both 15 and 6 have the same common factor 3, right? So we can write like this. Okay, 3 times 5, 2 times 3. So you can see both of them have a number, have a prime common factor 3. So that's why we can cancel out them. Okay, 3 appear at the top, 3 appear in the bottom. So we can cancel 3 here and 3 here. So now, when you cancel them, so the only thing left is a 5 and 2. So now the fraction is a 5 over 2. So it is the method to simplify a fraction. Okay, it's very useful for you later on when you learn how to multiply fractions with each other, multiply and divide fractions with each other. Okay, now we continue with the second example is a 99 over 69. Okay, so I write it again here, 99 over 69. Okay, so this one, this fraction, they are big number, right? So because they are big number, so we cannot use multiplication table here. We only can use some rule, like how to find some rule. I will talk about it while I'm doing it. So 99 over 69. Let's see if we can find a product of of prime numbers of 99 and a product of prime number of 69. Okay, so let's start with 99. So 99 can divide by 2. No, because the ending number is 9, and 9 is an odd number. It's a not even number. That's why it cannot divide by 2. And if it cannot divide by 2, it cannot divide by 4, by 6, by 8, by 10. I mean any even numbers. Okay, so now we just look at the next prime number, 3. So can 99 divide by 3? The answer is yes. And how can you know? Because if you add two numbers with each other, so 9 plus 9 equal to 18. Okay, and then 18 can divide by 3? Yes. Or another way, continue, 1 plus 8 equal to 9. So 9 divide by 3? Yes. So that's why 99 can divide by 3. Okay, so 99 divide by 3, what is the answer? So you can do it outside like this. So 99 divide by 3. Okay, so we just do division here. So 9 divide by 3 is 3. 3 times 3 is 9. And if you subtract, it's just a remainder is 0. And then you drop the second number 9 here. So you have a 9 divided by 3 equals to 3. And then 3 times 3 equal to 9. And 9 subtract 9 equal to 0. 0. So the remainder is 0. Okay, so no more numbers to divide. That's so the answer is 33, right? So now you ask yourself again. Okay, so we have the first prime number 3. So now the result is 33. Now you ask yourself again, is the number 3 is the last prime number of this tree? No, right? Okay, so let's check. Can we break down 33 equal to what times what? Okay, so 33, because the ending number is 3, so it is odd number. It's not even number. So it cannot divide by 2. Okay, so the first prime number 2, we can ignore it. So now, can 33 divide by 3? It seems so, because we have a 2 number 3 here. And the thing is checked is like this. 33 is 3 plus 3 equal to 6. So 6 can divide by 3. That's why 33 can divide by 3. Okay? And we write 3 here. Okay? So let's see. 33 divide by 3. Okay, so 3 divided by 3 equal to 1 here. Okay, and then we have a 0 remainder, and then we drop 3 down, and then 3 divided by 3 equal to 1, and 1 times 3 equal to 3. Subtract them, and then the remainder is 0. Yeah, so it means the result is 11. So 33 can be written as a product of 3 times 11. Okay, now 3 here is a prime number. Good. So 11 is a prime number or not? Yes, it is a prime number, because 11 only can divide by 1 and itself, right? It cannot divide by anything else. So that's why 11 is the last prime number. Okay, so now is the last prime number. 11 is the last prime number of this tree. So we stop here. Okay, so 99 can be written as 3 here times 3 here times 11 here. Okay, so that's the top one. Now the top is done. Now we go to the bottom one. Okay, 69. Okay, so 69. So 69, so let's check. Of course 69 is a prime number or not. So we must check to see if 69 can divide, can be written as a product of any prime numbers or not. Okay, so 69, because the ending number is 9, it's not even number, it's odd number, so that's why it cannot divide by 2. So ignore 2. So let's start with 3. Okay, so 69, 6 plus 9 equal to 15. So 15 can divide by 3, right? According to multiplication table. So that's why 69 can divide by 3. So write 3 here. And then we just do division on the side. So 69 divided by 3. Okay, so 6 divided by 3 is 2, right? And then 2 times 3 is a 6. So 6 subtract 6 is a 0 remainder. And then we drop the number 9. Okay, now 9 divided by 3 is 3. 3 times 3 is 9. So subtract, so remainder is 0. Okay, so no more number to divide. Okay, so the answer is 23. Okay, now you ask yourself, 23 is a prime number or not? It seems so because you check. 23 divided by 2? No. Can divide by 3? No. According to multiplication table, you can check. 23 can divide by 4? No. By 5? No. 6? No. 7? No. 8? No. 9? No. So on and so forth until 22. Okay. Of course, 23 can divide by 23 because it's a prime number, right? So, okay, so 23 cannot divide by any number from 2 to 22. So it must be prime number, okay? Because it only can divide by 1 and itself. So 69, so 23 is the last prime number of this tree. Okay, so 69 can be written as a product of prime numbers 3 times 23. Okay, so now the fraction 99 over 69 can be written as like this. So the top one, so we have a bow here, okay? 3 times 3 times 11, okay? And 69 we have to the bottom, 3 times 23, okay? And look at them, okay? Both of them have a common factor 3. So here has 2 number 3s. Here has one number 3, okay? Because here has one number 3, of course we cancel 1 here. If we cancel 1 3 here, we need to cancel 1 3 here as well, okay? That's it. 1 3 here, 1 3 here, that's all. We don't have any other numbers in common, okay? So the answer to simplify this fraction is 3 times 11 over 23. And if you multiply, 3 by 11, you will have a 33. And the bottom is a 23. Okay? So this fraction can be simplified to become 33 over 23. Okay, so this is the way to simplify fraction, and it is also case 3 of fraction where a and b are not case 1 and case 2 above, but they have a common factor. Okay, and case 4, so case 4 is very simple. Actually, I should do it as case 3. Okay, so case 4, a and b are not case 1, 2, and 3. So what does it mean? It means a, b are not equal each other. Okay, so it means a different from b. Okay, a is not a multiply of b, and a and b do not have a common factor, right? So in this case, what does it mean? It means both a and b are prime numbers. Okay, and example for this one, 2 over 3. Okay, so let's check. A equal to 3? No. A is a multiply of 3? No. 3 is a multiply of A? No. A and B have a common factor? No. Right? And actually, if you don't remember what is case 1 or case 2 or case 3, then just remember one thing. A and B are both prime numbers. Okay? So in this case, 2 and 3 are prime numbers. In this case, you cannot simplify the fraction any further. Okay? Any smaller. No, you cannot. You cannot simplify it any further. Okay? Just keep it like that. So the another example is 3 over 5, 2 over 7, 11 over 13, so on and so forth. Okay, so long as a and b are prime numbers, okay, then it is the most simplified fraction. Okay, anything else? Maybe 1, 2, 3. Yeah, like 203 over 11. Yeah, it is 203 is a prime number, 11 is a prime number. So so I already talked about fraction and 4 cases of fraction. Okay, so that you have a some idea about fraction. Okay, so fraction is a simple thing. It's just a over b, and actually fraction is a division. Okay, a divided by b. Okay, and we make it into 4 cases. Like a can divide by b or a cannot divide by b, right? So the first 2 cases, case 1 and case 2, a can divide by b, right? B can divide by a. No, b cannot divide by a, but a can divide by b, sorry. Okay, so case 1, a equal to b, it means a can divide by b, right? 2 divide by 2, 3 can divide by 3. They are all equal to 1, right? Where a equal to b. Okay, case 2, a can divide by b. Yes, because a is a multiply of b. So of course a must be able to divide by b, right? And case 3 and case 4, case 3 and case 4, you can generalize it as A cannot divide by B. Okay, but we break it into two cases. Case 3, as A and B have a common factor, and case 4, A and B do not have a common factor. Okay, and actually case 4 is a very simple thing. We don't have much thing to do with case 4, but case 3 is very important, because you will use case 3, especially the Chi method, to break down both the numerator and denominator as a product of prime numbers by using the Chi method like this. It's a very important. Case 3 is very important when you do addition, subtraction, multiplication, and division of fraction. Case 1 and case 2 simple, right? Case 4 also simple. So the most important thing is case 3. Okay, so let's finish this lesson of fraction at this point. For next part, I will talk about a mixed number. Okay, so bye bye for now.